Section 3.2, the periodic table. When we look at this picture of the periodic table of elements, which is the same image as the inside cover of your book, it doesn't look all that exciting. But humor me here and let's look at just a little bit else. So here we have Beecroft's periodic table. And so this was a big thing that when I retired, that my students made for me with their faces in all the different elements places. So yeah, that was pretty exciting. But actually what I really wanted to get to was a periodic table that, if you go to periodic or well, you'll see what you can go to. You look at periodic tables and look at this periodic table and look at all the amazing things, and that this table looks much more exciting than just the plain table on the inside of our cover. And the periodic table, these elements are very exciting. Let's go over here to sodium. I'm going to click on that. And notice these soft silvery sodium chunks were cut with a knife and stored under oil. In air they turn white in seconds. Exposed to water they generate hydrogen gas and explode in flaming balls of molten sodium. And so there was more to that if you want it. And then let's go over here to chlorine. Chlorine is over here. Chlorine, a pale yellow-green gas. Chlorine killed soldiers in World War I. Today it mainly purifies drinking water and swimming pools. Combined with sodium, chlorine makes common table salt and is thus essential to life. Let's do a couple more here. How about carbon? A girl's best friend. Diamond. Girl's best friend. A diamond is forever. At least that's what James Bond thought. But there's actually different allotropes, not that you need to know that name, of carbon. Diamond is one of them. Graphite is another. You've heard of graphite probably if you played tennis, the graphite racket or your racquetball. Some other examples that's now being studied, the buckyball model. They're able to do things with that, and they're learning that, okay, maybe they can do even more things with that. And let me go right here. Pencils. You may wonder, well, let me see where our pencils were. As a different allotrope, let me go down here. Here we go. Handmade pencils. And so the pencil lead in pencils is not lead, by the way. It's actually graphite. All right, let's go to another element. What about sulfur? Have you ever wondered why Yellowstone National Park is called Yellowstone National Park? And if you've ever gone to Yellowstone National Park and you've seen some of those vents and the yellowness around, and the vents kind of smell a little bit, well, that's from the sulfur. Okay, and let's go and do one more. Let's come over here to selenium. All right, selenium occurs in fairly pure form in nature. This native selenium is exactly as it came out of the ground. It is used in many light sensing applications. And you know what I thought was interesting about selenium? Notice here, if you've ever had dandruff, Selsun Blue shampoo. Selenium sulfite is used in dandruff control shampoos. No doubt the cell in Selsun comes from this ingredient of selenium. Anyway, so as you can see, there are a lot of things that you can do with the elements in this periodic table. Actually, the elements in this periodic table, everything that makes up this world is made of these elements in this periodic table. So let's continue. On the periodic table, elements are arranged according to similar properties. If they are going in a vertical column, they're called groups or families, and they contain elements that have similar properties. Whereas the periods are horizontal rows of the elements. And it goes in cycles, hence periodic table or periods. So when we look at this as an example, so the group 2A is going to be in this column that goes down, whereas period 4 goes across. And you go, well, where did period 4 come up with? Well, because it's the fourth one down, the fourth period down. So here would be the first period, which would just be of these first two elements, hydrogen and helium here. Second period would be here. Third period would be here. And then fourth period. All right, so you're getting the idea between groups or families and periods. So you'll notice on this periodic table of elements that when we look at the different groups, we have these things called representative elements, and then down here we have transition elements. So when we're labeling our group numbers, for our representative elements, we're going to number them A's. So the first one, 1A, 2A, we're kind of like closing our eyes and ignoring these transition elements. So it continues 3A, 4A, 5A, 6A, 7A, and 8A. And that's kind of an important thing to be able to do later on when we're identifying how many valence electrons there are, etc. All right, so we just mentioned that with the groups for the representative elements, they're labeled the A's. The transition elements, we label them B's. All right, well, along with this, as we look at the representative elements, a couple of these groups, i.e. families, have very specific names. So the very first family, the 1A group, alkali metals. The second family, group 2A, alkaline earth. We're ignoring transitionals. 3A through 6A, no big deal on those names. But 7A, this second to last family that's all the way over to the right, is halogens. And that term's used a lot. And the last family, noble gases. So alkali metals, the first family. If you look at that, you may go, wait a second, where is hydrogen? Because when I'm looking at my periodic table, hydrogen is in that very first family, the very first group, and it's right above lithium. And why don't you have it there? Well, because hydrogen's not a metal. Hydrogen is a nonmetal. And so when they are including the alkali metals, that's going to be our lithium and our sodium, potassium, rubidium, and cesium. Okay, if we go all the way over the second family from the end on the right, we mentioned halogens. Halogens actually come from a word meaning salt forming, and they include your chlorine or your bromine or your iodine. And you'll know they form salt, like sodium chloride. All right, so press pause, see if you can identify the element described by the following. Okay, so we look at group 7A, period 4. So when we go over here, group, that is the vertical ones to the seventh one. Okay, I've done that, and that's where fluorine is starting, but it's period 4. I go 1, 2, 3, 4, and that ends up going down to bromine. Okay, group 2A, period 3. Okay, so group 2A, that is the second vertical column. So I see that we're starting out at Be, beryllium, and then we're going to go down 3, 1. We remember to count hydrogen. That's the first row. All right, the first period. 1, 2, 3, and that's magnesium. And group 5A, period 2, there we go, nitrogen. All right, we need to be able to identify metals, nonmetals, and metalloids. So let's look at this heavy zigzag line. They also call it a stair-step case or staircase line here. So everything to the left of this is metals. As soon as I say that, you may go, well, hydrogen's to the left of it. It's not a metal, I know. In chemistry, almost as soon as you say everything, there's almost always an example of something that's not valid for that. But anyway, so everything to the left of our stair-step case line, except for hydrogen, is considered a metal. Everything to the right is considered a non-metal, except some of them that are right along and border the stair-step case here. In that case, they're going to have tendencies of both. They're going to have slight attributes of metals and nonmetals, a little bit of both. So that's why they're going to be called metalloids. All right, we know that metals are shiny and that they conduct electricity well, and nonmetals are just the opposite. Whereas metalloids, well, they have a little bit of both. And one of our most famous metalloids of all is our silicon, which is, our Silicon Valley. Why is Silicon Valley called Silicon Valley? Because they make a lot of computer stuff there. And what do they use to make the semiconductors? Oh, there's our silicon. All right, so here are some different characteristics. So, learning check, identify each of them as a metal, a non-metal, or metalloid. Remember, all you do is you go to your periodic table and you look and see where it is in relationship to the stair step. Okay, so press pause and please do that. All right, I'm hoping that you were able to go and look to see that if it was to the left of the stair step, then it's a metal. If it was to the right, it was a non-metal, except those right along the stair step, except for aluminum, is a metalloid. So there's our silicon. All right, list all the elements that match the description. So this is going to be our last little problem check to do. And so find the metals in group 4A. So they're asking, do you not only know where group 4A is, but can you figure out which ones are metals and which ones are non-metals? And B, the non-metals, and C, the metalloids. So press pause and see if you can get that. All right, so there we go. You may go, wait, I thought carbon was in group 4A. Yeah, but carbon's not a metal. Okay, and so on B, you'll notice again the non-metals. So we have our nitrogen and our phosphorus. And then our metalloids would be our silicon and germanium.